Hi, this is Michael. I'd just like to give you a rundown on the latest power distribution board from RCC SKJ and also distributed by Ostar Models. This unit is the red or orange unit, I guess you could call it, as opposed to the upper spec black power board. This one doesn't have the BEC. The actual voltage to the receiver is set at 5 volts, but the voltage to the battery, to the actual servos has no regulation. So basically, whatever the battery voltage you put into the unit, up to around about 12.6 volts, is what you would get out to the servos. So there's no adjustment to the servo voltage. So your battery selection would be quite critical in using this unit. Everything else is fine, it works really well, but just make sure that you're using something like 6.6 LiFe's to run the unit. That'd be fine to power your servo, especially digital servos. 6.6 volts would be okay. I'd start to get a little bit worried if I was using anywhere up to around about 7.4 LiFe's or something, because it may be at the higher end of your servo capacity. The unit itself has 12 receiver inputs and also 34 servo outputs. As you can see, some of these have dual servo outputs on each channel. Others actually have up to 4 outputs on each channel. Just makes use of a Y lead redundant, so there's be no need to use a Y lead. You have an audible and visual alarm. If for any reason your battery is low or your battery is disconnected, the audible alarm will go off, and it'll also give emitting a light beacon as well, just to warn you of the fault. There's a digital display to give you the actual battery 1 and battery 2, U1 and U2 inputs from the batteries, a switch to turn the unit on and off, and also a little power switch, remote power switch here for the CDI ignition. This section here is just for the CDI. You have the light to let you know what the voltage is. Green light gives you voltage between 4.8 6 volts. Once it starts going red, it means that the voltage to your CDI ignition is dropping, and that's a separate battery that you would use. Anywhere from 4.8 up to 6 volts is suitable to use on the system. And then you have your output to your CDI, and then a little green indicator light to let you know whether it's armed or turned off. When the unit's turned off, the CDI, the little green light isn't on. When the unit is turned on and there's power going to the CDI, the green light comes on. As I said, this unit here, battery power comes in, goes through that switch, activates at the switch, and there's just a little signal back to that to get the switch to open. Or to close I should say, when you take the power off and shut the switch down via disconnecting the batteries or turning off at the actual switch here, it shuts down this unit and isolates your battery to the CDI ignition. Just a little bit of a safety feature. You can fit 2 receivers in this area here, so if you wanted to have 2 receivers back side by side, they'll fit in quite nicely. On the back of the unit have a circuit board display, a schematic, and it just gives you some of the parameters here. So input voltage 4.8 up to 12.6, output voltage 4.8 to 12.6. So whatever you put in will be what you would get out of the servo. So that's why making certain that the batteries that you pick to suit the servos that you're operating is fairly critical with this unit. Apart from that, it's very similar to the other black power distribution board that's available as well. First thing I would do before actually setting this system up would be to make sure that the voltage is correct. So I would use my multimeter first up. just a standard little multimeter. Put in the battery, and in this case I'm using 6.6 LiFe's. Connect the other battery in. Okay, turn our multimeter on, then turn on the power unit and see what we end up with. We end at just over 5 volts to the actual receiver, so that's fine, everything's okay there. As you can see, we have a display U1, which is battery 1, this battery here, 6.6 volts, U2, this battery, 6.57 volts, so our battery voltage is great, there's no problems there at all. Turn the unit off. Just double check what we're getting at our receiver, just to make sure. Like I said, you can't control the, or you can control depending on the battery you use, or whether you use a regulator in between the battery and the system. But whatever you put in, if you connected a battery straight in, that's what you would get out at the actual to your servo. So, as I said, without repeating myself, it's fairly critical that you use the right batteries to suit your servos, or at least have them regulated. Turn the unit on, and there we are. We're getting 6.6 volts to the servos, so everything's fine there. What we're getting on the meter here is exactly what we're getting off the multimeter, so everything's okay. Power the system down, disconnect, and then what we can do is connect up our receiver. What you'll notice, you'll get a couple of a number of connecting leads, these ones here. You'll have 2 of these which have just a standard male to male with 3 wires on each one, and a little tab. That just makes a little bit easy when you go to locate it into the actual unit, because there's little cutouts in each one of these inputs and outputs. So you can see a little tab there. Very similar to a few-tarbit connector. Then you have 2 of these, 2 lots of these. As you can see, they have male to male again, little tab on there, but they only have 1 wire to each one, and that wire, if you notice, is the signal wire, and they're just coloured because just the way it's probably been easy to manufacture. But the reason for this is that your receiver is supplied power via one of these connectors, and it has power going to it. You only need to use these wires to transmit the actual signal line from the receiver to the unit itself. So it's pretty straightforward, and I'll go through that, how to connect it in. Have our receiver. I put a couple of wires in place. As you can see, number 1 has the 3 wires going to it. That'll be our main feed to our receiver. So put the receiver in. Okay, connect our number 1 wire in. Connect our single wires for the actual signal lines. Just go with our colours. It doesn't matter which way you have these normally, but you know, you could have white, red and black, you could have red, white, black, doesn't really matter, but just for this part of the demo it'd be a lot easier just to make sure that you connect up the colours so that you don't get them crossed over, and you know which servo you'll be operating, or which channel you'll be operating. So we have white, red and black. And black. Then I've got one extra here, and that's got that has the 3 wires on it. and that is for the CDI ignition. So I'll just plug that one right into the end. So there we have it. There's our system there. Just to prove that we've wired it in, I'll turn it on. And we have a little red light come up on our receiver, so we know we have power to the receiver. Everything's fine there. Also we have mounting grommets and screws, especially for petrol models where you may have some vibration. These would help with the support and security of the actual unit itself, and also try and eliminate a little bit of vibration going through the unit and into the receiver as well. Now we'll just connect in a couple of servos. Just make sure we get our polarities right. You can use digital, you can use just standard servos, doesn't really matter. I'll connect 2 servos to this output here just to show that we don't need a Y lead. Okay, there's our servos connected in. Grab our transmitter. Turn the power on. And now we have the servos connected up. Transmitter on. And then you can see the other 2 connected in together without a Y lead. Now while we're connected in the system like this, we'll just go through the actual battery backup. If for any reason the switch was to be disconnected, the system still works. Plug the switch in, turn the switch off, unit powers down. Unit's powered down already. I'll just show you what happens if you were to disconnect the switch, pull the switch out. If it failed during flight, the unit comes back on. Battery 1 or battery 2, doesn't matter whichever. Battery 1 disconnects. Power on. It's showing that battery 1 is connected, battery 2 is the one that's not connected, 0 volts, because it's been pulled out of line. So it's either gone flat or it has disconnected or failed in flight. Connect it back in, and there we have the system working. Same again, if I was to disconnect with the unit turned on, battery 1, U2, okay. U1 is a unit that's failed. As you can see, the flashing light coming on. Connect it back in. Turn the unit off. Now we'll look at connecting up the CDI ignition. So this, I'll disconnect the remote switch out of there. I don't need it for this. It's easy to just connect the battery supply straight in. I've got 2 batteries here just to show, one at full charge and one at low voltage. System connected in. You would then connect the CDI, which I have here, into there. Make sure we got this in the correct way. Connect it in, and there we have the CDI ignition connected up, and that's all there is to it. If you were to turn the unit on, you notice you've got a red flashing light. That means that our battery, which I'm using here, is low. and that's why you're getting the flashing light. It's around about 4.4 volts. Also, the CDI ignition is turned off. There's no power going to the CDI. If I was to hit the switch, that would then activate the CDI. So at the moment we have a low battery, so we need to rectify that. Turn the system off. Disconnect this battery. I have another one here we can connect in. This one's charged up a little bit more. Turn the unit on, and as you can see we have a green light showing that the battery is charged. The other thing with this system that I like is that you don't need to worry about using one of those UBECs, so long as you in line to try and bring your voltage down. Some systems have them set up that you can use your lipos, and you've got to use a voltage regulator to go in to drop the voltage. You can just plug in a standard 4.8 battery, or you can even go to a 5-cell if you wanted to, and just plug it straight in. So it's pretty easy and pretty standard to do. Shut the system down. Disconnect. And as I said, the unit itself has one other feature, and what it is, you can set the actual voltage alarm so that if this voltage battery was to drop, say to you may say 5 volts, you can actually go into the system via this little button here. Just use a pen or something similar, push it down, and it lets you know 4.2 volts. Now you can increase that to 5 volts. So once the voltage drops down to 5 volts, the alarm will go off to let you know that your voltage has dropped down to that level. Not a bad little feature, and just something that just gives you that little bit of extra warning that if there's a battery issue. So yeah, it's a pretty good system. Like I said, I've tried these out and found them to work quite well. So for general use in aircraft, I think they'd be a good unit. Thank you.